Laplace transforms part 4, the unit step function. I omitted this part from my previous video, but realistically, it was playing a part. This table that you saw, technically that's wrong. It should actually be this table here. Comparing the differences, the function of s is still the same, but notice in the function of time, they've all been multiplied by u of t. So what is u of t? It's the unit step function. But what is the unit step function? Well, in short, it's the function that we're multiplying by the entire equation to say what actually happens to it. So u of t will be equal to 1 if t is greater than or equal to 0, and it will be equal to 0 if t is less than 0. Demonstrating this graphically, if the horizontal axis is t, and the vertical axis is u of t, we've got the origin point obviously of 0, and if t is less than 0, it's going to be 0. Then we reach 0. We're then saying u of t is equal to 1 if t is greater than or equal to 0. So at the u of t axis, at 0, we actually jump to 1, and then u of t is equal to 1, and it will become 1 forevermore. What's this representing exactly though? Well, the Laplace transform is applicable between 0 and infinity. And one of the reasons behind this is if we're thinking of t in terms of time, we're not going to be applying things back in time. Practically speaking, time starts at 0 and then moves forward. So anything that's back in time doesn't exist. So that's why we're saying that if the time is back in time, then the u of t equals 0. However, any point between now, the starting point, and ahead, it exists. Let's apply that to an expression. We have 5t cubed multiplied by u of t. Technically speaking, u of t was always there. I just ignored it. If we want to look back in time, say at minus 20 seconds, then our unit step function states that, well, u of t must then equal 0. And if u of t equals 0, and that's been multiplied by the entire expression, it doesn't matter what we do with the Laplace transform, because it's all going to equal 0 either way. So f of t will become 0, and the function of s will also be 0. However, we're going to assume that we're never going to be looking back in time, because if we're looking back in time, it's always just going to be 0. So we're just always going to assume that u of t equals 1. Because we're looking at the point in time from 0 onwards, but never back. So if u of t equals 1, this whole expression is multiplied by 1, so it would just be the Laplace transform of 5t cubed. And we can work through with that to give us a final answer of the function of s equals 30 over s to the 4. So we're using the exact same skill as the last video, we're just adding the extra important element to it that's always there, and I'm showing you how to deal with it. And dealing with it just assumes that u of t equals 1, unless stated otherwise. Try the 3 questions out with u of t being involved. Remember, u of t equals 1, and as you can see, u of t has been multiplied by each of the entire expressions. Pause the video and resume when you're ready for the answers. Hopefully that was easy enough of comprehending how to deal with the unit step function. Fully written out answers are on my website and a link in the description below. It is also worth noting that there is a heaviside function, but I'm not going to deal with that. However, I'll leave a link to the video on screen. The next video covers the first shift theorem. Stay safe and healthy, and I'll see you in the next video.